All right, so for this particular video, I'm going to be sharing my screen with you. So hopefully you can see the slides just fine. Apologies for not constantly looking at the camera as I reference the material to make sure that I'm giving you correct information. I will try to remember to look at the camera as well, but it's an interesting setup that I've got here. So thank you for your patience and your understanding. But for this particular review, we're going to be looking at classification. Now, classification, this is a concept that is carried over from 7th grade when we started looking at the level of organization that we provide for organisms. Keep in mind, as far as why do we classify things, this is a matter of organization, as I pointed out, and because it allows us to keep track of everything. We're trying to minimize confusion, as you can see here on the slide. So we needed a way of organizing all of these different species, and there are so many different species of both plants and animals and fungi and bacteria. And when you look at the entirety of all the organisms on the planet, it becomes overwhelming. It's just too much information. And so scientists are typically going to look for ways to organize information in a way that makes it more manageable, makes it easier for us to study things, and also makes it a little bit easier for us to share information with other people. So if we can agree on a way of organizing content, it allows us to communicate with each other a little bit better, specifically within the scientific field. So that's the main purpose. Like, that's why we classify organisms. In terms of why we use Latin names, we had to pick a way of identifying organisms that could be more universal. And so Latin names were used, and you can see the example here with mountain lions. We're familiar with mountain lions. We've heard of the term mountain lion, but mountain lions are also cougars and panthers and pumas, and they have all these distinct names based on regions. From state to state and from country to country, certain organisms have different names based on whatever the region decided to identify that organism as. And so as such, we want to make sure that when we are discussing an organism, that we all are in agreement that it's the same thing. And so we've decided on using Latin names, and we have this breakdown that we use, binomial nomenclature, that allows us to identify organisms based on how we've organized them, based on how we've classified them. So as you'll notice here, that allows us then to look at ways to kind of determine what they are, to separate them into categories. Now, dichotomous keys, once again, this is a carryover from 7th grade. Dichotomous keys are a way for us to take new organisms that we've discovered, new species, and new species are discovered all the time, and figure out what category they need to go into. How do we classify this new organism? And so we go through this, basically a flow chart, a little yes or no type situation, where we look at specific characteristics. If you're familiar with those choose your own adventure books or choose your own adventure type games, where if you decide that this is something you want to follow, then you move to the next step. It's a very similar setup. And so what you'll do is you'll always start with number one. And in this case, here's a dichotomous key for writing implements, right? For writing implements. Here I've discovered a new writing implement, and I'm trying to determine how to classify it. And so what I'll start with is number one, it says, does it write with ink or does it write with graphite? Well, in this case, this writes with ink. So that tells me to go to step two or number two. And when I go to number two, it says, is the writing tip metal or is it felt? Well, in this case, the writing tip is metal. So I'll go to number three. Writing tip contains a ball or writing tip does not contain a ball. And this one does contain a ball. So that has already identified this as a ballpoint pen. I don't need to go to number four because I've already identified what this new object or organism is. And so we use dichotomous keys that are based on descriptors or characteristics for each of the groups that we're going to be looking at here for classification. Okay, so our dichotomous key is useful when we find something new and we're trying to figure out where it goes. In terms of organization, where does it go? All right. This leads us into cladograms. And this is a content, that we've already covered, but cladograms are interesting because they allow us to look for these traits that separate organisms, but also identify how closely related organisms are to each other as well. This allows us to identify common ancestors or who has the most recent common ancestor. And so typically what we'll look at with a cladogram are a lot of those physical characteristics or traits that allow us to classify organisms. And so when we look at this cladogram that we have here, starting with sharks and ending with birds, obviously all of these organisms have very distinct differences. But when we're looking at those characteristics that allow us to classify organisms, we can find some similarities. And the way that we're going to read this, if you look at the very bottom, The first characteristic at the bottom is vertebrae. Vertebrae meaning having backbone, right? So everything after the trait or anything above the trait will have that trait. So the very bottom here, the very first characteristic listed is vertebrae, which means every organism on this cladogram has a vertebrae. As we move up to the next characteristic, bony skeleton, well, now the shark is not after that characteristic, it's before it, which means it does not possess that trait. That is one way that we've separated the shark from all the other organisms. One, it has a vertebrae. That's one thing it has in common with everything else. However, it doesn't have a bony skeleton. So that's the first characteristic that we've allowed to isolate the shark from the rest of the group. After bony skeleton, we then move into four limbs. This is now excluded the fish, right? The ray fin fish. It does not have four limbs. It does have a bony skeleton, but as you'll notice, as it says here, everything above the trait in line has it. Everything below that trait does not. So when I get up to amniotic egg, then you'll notice everything above amniotic egg, primates, rodents and rabbits, crocodiles and birds, all possess that trait, right? Amphibians, ray fin fish, and sharks do not possess that trait because they are below that characteristic. And so as we go up this list, we'll see little branches of organisms, offshoots of one another that share specific characteristics. The points of intersection are really worth noticing if you can see my cursor here. So like for crocodiles and birds, there's a point of intersection that they run into each other. That point of intersection is indicating that they have a common ancestor at that point. There was speciation that occurred from an organism that allowed crocodiles to split off into one section and birds to split off in the opposite direction, and obviously start to show some of those distinct differences amongst the organisms. And we know there's plenty of differences between the two. Please keep this in mind. It's about the points of intersection. Now, I know that rodents and rabbits are right next to crocodiles on this cladogram. Crocodiles are right next to birds. Primates are right next to rodents and rabbits. However, it's not the placement at the top that's determining who has the most recent common ancestor. One second. Little musical break for us here. Those of you obviously at TCHS know that that's our indicator for attendance purposes. So obviously nobody's here, so I don't need to take attendance. But anyway, nice little musical break for us. Anyway, as I was saying, the organisms at the top, when you look at the placement, how they're next to each other, that is not the main indicator that they are most closely related. It is part of it. Obviously, birds and crocodiles being closer together on the cladogram show that they are more closely related to each other than birds and sharks are going to be, which are on opposite ends of our cladogram. However, to find the organisms that are most closely related based on a common ancestor, we have to look at those points of intersection where the lines meet. And so we'll notice here crocodiles and birds share a more recent common ancestor than crocodiles and rabbits, because we have to come all the way down here to find the common ancestor that links crocodiles with primates or crocodiles with rodents and rabbits. Rodents and rabbits also share a more recent common ancestor with primates, right? Which is why you have this little branching off section here, than they do with crocodiles and birds. So we could essentially switch rodents and rabbits and primates as far as the order at the top. We could switch them and everything would still be the same in terms of who's more related to who or who has a more recent common ancestor. Once again, we're looking for those points of intersection to determine that. How we're going to read this, once again, a little quick recap here. Every characteristic that's listed on the side there, if you're after the characteristic, you possess that trait. If you're before that characteristic, you do not possess that trait. So eggs with shells, everything above eggs with shells would be crocodiles and birds. They have that trait. Everything below eggs with shells does not have that trait. Rodents, rabbits, primates, amphibians, ray fin fish, and sharks do not have eggs with shells. Everything below the characteristic or before it do not have it. Everything above or after will possess that trait. And it's these distinct differences that allow us to organize these organisms. And that gets us into the breakdown that you should most likely have seen way back in 7th grade. And I know that was a few years ago, but this is where we get into how we name organisms, but also how we organize them into specific categories. And that will be based off our domain, which is the least specific. So if I said, you know, animal kingdom, right? Or animal, animalia, that's anything that would be considered an animal. If we're looking at things like eukarya for a domain, eukarya is anything that has multicellular, right? Multiple cells, right? Membrane-bound organelles, a nucleus. So domain eukarya is for anything that's multicellular. That includes plants, animals, fungus, everything that's multicellular. That's a very, very generic category. So notice domain is least specific. When I say kingdom Animalia, now I'm not talking about plants and fungus. I'm talking about just animals, all animals. And then we get more specific with phylum, and then more specific with class. And then we get very, 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 very specific all the way down to the bottom where we get into our species. This is the most specific way that we organize any type of organism, plant, animal, bacteria, whatever, because there's only one of each species. So just to break this down a little bit easier for us, as I mentioned, for domain, there's really just three that we focus on: bacteria, archaea, and eukarya. Eukarya is anything that's multicellular. That includes all plants, all animals, all fungi. Anything with more than one cell that makes up its structure is going to be in that domain, right? That domain is huge, very generic, lots of organisms in that specific domain. But if I say species, let's say canine, right? Now we're talking about dogs, right? Maybe wolves, but we can get more specific if we want. But if we're talking about just dogs, that's a species. And that excludes anything that's not a dog. And so we go from least specific to most specific in this order: domain, kingdom, phylum, class, order, family, genus, and then species. There is a little mnemonic device to help you remember the order here. Did King Philip come over for great soup? There are so many different mnemonic devices to help you remember the order of each of these classifications. Pick the one that works for you. If you want to do a quick search to find the one that will help you remember it the best, by all means. But I will say that we will focus primarily on domain and kingdom, as well as species, when we start looking at questions that are tied to this particular unit. All right. But I do want to go back just real quick. After all of that, looking at cladograms, looking at dichotomous keys, and then talking about the actual breakdown of classification that we use from domain all the way to species. Once again, what's the point? Why do we classify? And if you notice here, we just wanted a way to organize all of these new discovered species so that there's no confusion, right? Why do we use Latin names? We want to make sure that we pick something universal, something that if I'm talking about a specific organism here in Texas, and I'm speaking with someone, I don't know, in the Middle East, they're going to know exactly what I'm talking about. And then if they're talking to scientists in Germany, they're going to know exactly what we're talking about. We're all going to be using these agreed upon Latin names to identify organisms so that I don't say cougar and they're like, do you mean mountain lion, right? So we want to make sure that we're eliminating confusion. And when we're trying to study processes like evolution and natural selection, this allows us to see those connections, those common ancestors and those levels of speciation that occurred.
Especially for Falcons in the field house, portables, and downstairs North Hall, along with those heading to a K-Cal class.
I was just a little bit off. If I would have just finished a little bit sooner, we would have been fine. But anyway, the goal here is to make sure that we're eliminating confusion and have a way of organizing these organisms. All right, so that's it for today. Thank you so much for your time, and see you on the next video.